Hello friends, let's continue with our series. For the lecture number 16, we will be learning about random forest. Let's begin. So what is a random forest? It is a machine learning algorithm that combines multiple decision trees. It gives the final result based on a majority vote, which is classification, or average regression, right? So what do you mean by multiple decision trees? It is basically the combination of the decision trees that we last learned, and random forest is a machine learning algorithm which combines multiple of those decision trees, right? After the combination, it gives the final result based on majority vote. And what is majority vote? So basically when you vote for a party, you are voting for a specific group or a specific entity, and that is in competition with some other parties. So when you vote this one party and it becomes the majority party or the party with the majority of the votes, then this is considered as a majority vote party. And that's how the classification works. Whenever you use a machine learning algorithm, it combines several such votes, and the one vote or the one entity which gets most of the votes is considered a majority vote, and that is how a specific type is decided in classification. Or the average, which is regression, you already know how it works. So how does the random forest work? It takes random samples of the data and builds a tree on each, right? It will collect some random samples and generate a tree based on each of the random samples, and after that it also picks random features at each split. This makes the trees different, right? Apart from picking up the samples, it also picks up the random features at each split. This is how the tree turns out to be different. During the prediction, all trees vote. The majority result is used. As you know, the majority vote is done. During prediction, all of the trees cast their votes. The one with the majority wins or is selected. Why do we use it? It is more accurate and stable than a single decision tree, and you can probably understand why. It is also great at handling missing data, noisy data, and large data sets. So since it is based upon multiple decision trees, it definitely could, work with some missing data. If there are a lot of trees and one of the trees is missing some data, it is not a very big deal. If there is some noisy data, you can just not consider it and go on, because you have a lot of decision trees. Finally, large data set, not a problem. Also, it helps reduce overfitting, right? The problem of the overfitting can be fixed by using random forest. Let's look where it is used. It is used in fraud detection. It is used in medical diagnosis like cancer classification. It is used in stock market, loan approvals, recommendation systems. And finally, what are the limitations? It is slower to train and predict compared to one tree, because obviously there are multiple trees, and it is not easy to interpret or visualize, because if there are multiple trees, visualization can be hard. Even for some trees, the visualization is not easy, right? Well, that was all for this video. I hope you were able to understand. Thank you for watching.